doesn't fit.
The American worker, more often than not, he's been a victim. Instead of creating products with a grand vision and the resources to back him up, he's become isolated. In the end, there's nothing left but a solitary fight for survival. Life imitates art in this dilemma that has reached every sector of American industry. For the next several minutes, we'll discuss this growing industrial crisis and what General Dynamics has done about it. While the issues we explore may seem complex, the solutions rely on basic employee ideals: commitment to quality, teamwork, enthusiasm. It all boils down to the individual. Today, many U.S. companies create products in a vacuum, each station throwing its completed task over the wall to the next. We've simplified a complex issue, but I'm sure you've heard about or encountered some square pegs where you work. You know the real frustration caused by a vicious cycle of changes, rework, and more changes. The results of our self-imposed barriers have cost us dearly. Even though a product's design phase comprises a tiny piece of the development pie, decisions made early lock in the bulk of later spending. For a typical electronics product, costs rise dramatically as changes are made at each development stage. During final production, any redesign is especially devastating, an expensive alternative that must be remedied. And what of the human cost? How does one measure the effects of frustration caused by a system that doesn't work? During the 1980s, America's solution to this vexing problem was automation. We thought we could out-manufacture the competition with high-tech machinery. Unfortunately, American industry missed the point. Product development, unlike an assembly line, doesn't happen on a straight line. Rather, it's an intricate web. Individually, the threads are extremely fragile and easily broken. Molded together, we can create a fully integrated, powerful workforce. At General Dynamics Convair Division, we have a proud heritage to uphold. Over the years, people in the armed services and private sector have come to rely on us and our products. For some of our customers, quality means the difference between life and death. But our leadership role has been threatened. Increased complexity, competition, rising costs, shrinking defense budgets, all have had a major impact on our ability to win new programs and strengthen our future. It's ironic to think that while Convair's work contributed to the winds of change in world politics, it would also change the way we do business. We must change in order to survive. In an attempt to meet these challenges head-on, Convair has established the Integrated Management Systems Project. Perhaps you've read about or already heard about their ongoing efforts to develop advanced systems and tools, all aimed at integrating our product development threads. Just as important, though, is their emphasis on cultural changes in the workplace, a real shift in how we create products.
If you have to boil the IMS program down to its very basics, we're trying to provide for the generation and sharing of data from the development of a proposal to the government through design, through preparation for manufacturing, integrated logistics support, right through the retirement of the product that's been developed. And throughout that process, have a common database, one common database that everyone makes use of. Sharing data, being able to get the right data, is the key to concurrent engineering.
The effort in the IMS area with focus on concurrent engineering will be to consider the entire process from design to manufacture to maintainability, and to take those issues into consideration before the final design is released into manufacturing. Our focus now will be to develop a product with an emphasis on being able to manufacture that product. Selecting the right process and tools before we release it into production. We're going to try and do it right the first time.
For now, let's suspend what we know or what we think we know about IMS, total quality management, or concurrent engineering. You'll probably get a different definition of each depending on whom you talk to. Bottom line is, we need to develop new products quickly. Those products must be cost-effective and reliable. It's the only way we can increase our business in a rapidly shrinking marketplace.
Not just this program, but a lot of programs are being accused right now of being too expensive, not delivering the performance, and being late to schedule. In the environment that we're in, with the shrinking defense budgets and so forth, we still want the performance. We still want the best vehicles, the best weapon systems in the world, second to none. You got to find a smarter way to do your business. And one of those ways is to have this concurrent engineering, or as we put it here at ASD, the integrated product development. I am absolutely committed to concurrent engineering. I see that as an outgrowth of TQ. It's the right thing to do, and it's starting to work in a number of areas.
The right thing, not only for customers and contractors, but for suppliers as well, who, for the most part, build over 90% of what goes into new products. For example, at Williams International in Utah, where the engine for our advanced cruise missile is built. Their long-term commitment to fully integrated product development has begun to pay off.
We can trace it back at least 12 or 15 years when we started the concept called integrated teams, where we've decided that for us to get our product into manufacturing at the right costs and on the right schedule, the right quality, that you cannot do the design to production phase in serial, that in fact you really got to do it as a parallel effort. So in one of our programs back in the early 80s, one of the cruise missile programs, we started working with the concept of simultaneous engineering. And what's really good about simultaneous engineering is that you get the manufacturing commitment locked in way up front in terms of what does it take to bring that product on stream, make it at the right cost with the right quality, and sustain it throughout its life.
The engine company for us, Williams International, has been doing this for a number of years. I was up there several months ago, and we got started into this briefing. Every one of their engines, every one of the spare parts had been delivered to the user. That's the Army, the Navy, the Air Force, on or ahead of their schedule, at the price that they quoted on the contract, and at the performance that the user had asked for, the customer had asked for. And I said, stop. How did you do that?
Well, I would like to say it's the way in which we've modernized the last 3.5 years, because that's how long I've been here. But we've been doing it a lot longer than that, obviously. I think the key is several-fold. First of all, you have to have a nice, stable product. If you talk to the people that use the engines, our customers, you'll find that they are highly reliable, they're simple to maintain, and consequently there have not been a lot of design changes with our particular product as there may have been in other kinds of applications or other kind of engines. That's number one. I think number two is the whole concept of going through simultaneous engineering early on in the program, and then once the program is up and running, not forgetting about that concept, because we still have simultaneous teams to maintain the product during the life cycle of the product. When you step up to that kind of a commitment, and everybody knows from almost day one what's expected in terms of performance of that product, in terms of what the customer is looking for, in terms of our own individual quality goals and our cost goals, then it's very easy to make schedule. It's almost routine then to have that kind of performance, because all the other issues are out of the way. All the games playing are out of the way.
Suppliers are going to be our partner in the future. And it's not going to be by contract terms and conditions. It's going to be by a very close working relationship where we depend on them to not only deliver on time, but product that is supportive of the quality standard we must meet, the warranty requirements, the reliability that the customers ask for. We'll work together, not just electronically and communications, but as a team around the table, taking ownership of the total process. It's going to be something new for us to do. Our typical problems with supplied material are documented. We need to learn how to work together to manage the process better. We look forward to companies like Williams who are truly working hard to establish process controls, minimize the variability in the manufacturing process, improve the quality standards, if you would, so that every time we receive product from them, we can count on it.
Survival, sweeping cultural changes, advanced tools. There's certainly a lot to consider, and the stakes are high. By now, though, you probably realize that our most important resource, the one thing that will ensure fully integrated product development, is people. People who are willing to take the initiative, perhaps take a few risks, in order to recognize our need for change, then do something about it. Here at Lindbergh Field's Advanced Cruise Missile High Bay, where components are readied for final assembly, a total quality management committee has been established. This cross-section of hourly workers, chaired by a salaried supervisor, look for concrete ways to put these changes in motion.
We're going to have to work as a team together.
Exactly. The whole reason we're coming in with TQ is to allow you the opportunity to tell us how to do it better. For years and years and years, top down, management tells you what to do. Well, we're wrong. The folks on the floor are the experts, so you got to tell us. And then you got to stand up to that. You got to let the person, when he says this is the way to do it, you got to let him go run with it. In all the examples I've seen from other companies, employees are extremely smart and clever. And they're the first ones to say, bad idea, if it's their idea, bad idea. And they'll change it. So to that employee, I would say, you're important. Your ideas are important. You may be absolutely right to keep it the way you are. Let's sit down and talk about it and go from there.
Recognizing the value of our employees is especially critical during the early stages of new programs, like Convair's ACM variant. Established to meet the evolutionary needs of our Air Force customer, Variant will carry ACM through the 21st century. What better time to introduce a new philosophy which holds the same promise?
I'm trying to get it all set up.
I started out from my perspective of what is it we want to do different? What is it really we want to do different here on the Variant program? One of the experiences I lived through was the transition into production on the Tomahawk program. And we had a very, very difficult time doing that. I constantly asked myself why. What is it that's lacking here in terms of our ability to transition the systems that we design into production? One of the engineers who was a principal engineer in designing the MCM on Tomahawk, the Mission Control Module, he got called off of engineering to go down and help assemble that. And he came back from that assignment and he said, my God, had I known what I was doing here, I wouldn't have done it that way. How can we solve that problem? That's one of the questions I ask myself.
In the past, there's been consensus that our transition process has not been effective. Not being able to build it, not starting on time, shortages, test failures, change. Hurry up and do it wrong again so that we can effect another change. Typically what's happened is more teams are formed, more signatures go on drawings, more controls are inputted into the system, but the bottom line or end result is still the same. The parts just do not work well the first time we attempt to manufacture them or integrate them. The future says that the team is going to take total ownership of that component, that product, that system.
One of the fundamental principles here that I've established on the program is one of commitment of people for a fairly significant period of time. And so that if it doesn't work, there's no one that they can blame except themselves, because they've got an input in the design, they've got the ability to significantly affect the design and the outcome of the design. They're working together as a team. They're the ones that will be standing up to the customer and explaining all aspects of what they're doing. It helps, I think, get them focused on their real job in life, which is to get this job done, and to get it done on cost and on schedule, or ahead of schedule and under cost.
While there's nothing easy about our attempts to fully integrate product development, you can almost feel the energy, the excitement, when people truly believe they're making significant improvements. And it's not just designers and builders, but everyone involved with product development.
It radiates off of you. The attitude does radiate, so when I go to other departments, they're willing to support me when before they didn't. It's exciting. You're very proud to say, I work on the variant program. I work for General Dynamics. 6 months ago, I did not feel that way. In fact, the survey that came out, when it says, will you be here the next year? I said, absolutely not, and wrote comments about it. Things are quite different, and in only 6 months.
It's only about $15.
Oh,
What's
okay.
the easiest way to do that?
Well, we can go 2 ways. I don't know. The big difference is management is totally behind it, no matter what the issue is.
Supposedly she's got the breakout.
It's mind-boggling to me. But there's a purpose here, and everybody's they're on the same path to get the same goal. Where before, everybody's got their own little paths, and nobody knows what the goal is. They don't understand it. They don't care, you know. And now, everybody's on the same wave. Oh, it's wonderful. How can you not succeed?
And I think when we talk about the folks within the variant team, they have ownership. I mean, they get to see everything right there. You know, they design it, they work out all the bugs right there. It's not as if I do my little part and then that disappears and it's, you know, maybe a month or 2 or 3 later it comes back to me. You're responsible. You've got the whole 9 yards right there. And there's a certain sense of ownership and pride that goes along with that. And I think you see that in the folks who are on that project out there.
I'm excited, and I'm excited because the engineers, the manufacturing people, and the suppliers are all working together towards this goal. This is not just a manufacturing project, it's a team effort. I believe we're concentrating on the key issues that have caused trouble in the past, and I'm not predicting that we're going to have a perfect transition. I am convinced, however, that with the participation of the people involved, and with a common goal of a successful, high-quality transition, we're working the right problems. We're going to see that it does happen.
Yes, there's a significant cultural barrier that you have to overcome. But you got to overcome it, because if you don't, you're going to bury yourself. Someday you're going to realize that there's nothing coming over that wall anymore for you to do, because your competition has taken all your customers away.
If anything, we've learned it's not what we say, but what we do. Let's stop being victims and create a thriving, powerful workforce. Only your willingness to change will break the barriers and build our future.